Good morning. Welcome to lecture 13, Thermodynamics of Materials. So we will actually complete the relationship between enthalpy change and heat interaction. This you have said. So what is this? This we showed you. dH is general form. dH is dq, heat interaction is dH plus dW prime. This is the general form. And is there any restriction on this? Any restriction? Under constant pressure. Under this we discussed. Constant pressure. From which you get when no non-mechanical work, when the system involves no non-mechanical work, then dq is dH. Okay, this is actually found already under constant pressure system. For further matter, suppose I ask you, so enthalpy, what is enthalpy? Physical significance. What I said, two ways. One direct. One direct is what? Physical significance, I discussed this, so no point in discussing once more. So H is two ways to physical significance. If you ask me physical significance, just I am trying to actually continue from the past. So physical significance, last class. Physical significance is two ways. One is direct. What is H? Sir, H is, as we know, sir, enthalpy of this chalk, any material for that matter, is U plus P. This is the physical significance itself. With U we understand. We have already understood what is U. U is actually, as I told you, kinetic plus potential energy of the constituent particles. So U we know and PV we know. Together. Their sum is H. Direct. Second is in terms of changes. What is change? Last I said, if there is no non-mechanical work, say delta H, if you write Q is delta H itself. dq finite change for finite. When the change of enthalpy is what? What is physical significance? Its change is equals to heat interaction. Heat interaction is a measurable quantity. So this is a physical significance. Enthalpy change under constant pressure, because this is coming from this. Remember, this is coming from this integration of this out. dW prime is 0 W. And I can write and under constant pressure. Happy? Under constant pressure. This is very popular. Many a time you will see enthalpy change is considered as heat interaction. Heat involvement in the system, enthalpy changes. But remember, these two considerations are there. Under constant pressure and no non-mechanical work. This is not very uncommon, as we have said. So that's why we don't consider. Constant pressure is also common, very common. That's why this is actually very popular. Commonly used, and students don't know actually this may not be valid sometimes. For example, when it is not valid, constant volume, when pressure changes, even though there is non-mechanical work, no non-mechanical work, even though still under constant volume this is not valid. What is valid I will give you today. So this is not valid under constant pressure. So you have to consider constant pressure, processes with ideal gas, constant volume, etc., etc. So you should say, this is not valid. Now question, if the process is not constant pressure, then what is delta itself? Counter question now. Counter question. But very good, sir. If delta H is not always Q, heat interaction, for example, in constant volume process, then what is delta H then? The answer is delta H is delta H. This is the answer. Delta H doesn't have to relate with heat all the time. It can be changed of the process, not physically connected with the heat, not equal to the heat interaction, but delta H remains there. What is delta H? H of the final state minus H of the initial state, and H is we know. H we know. Final state has internal energy, has pressure, has volume. Get them together for final state. And for the initial state, get the difference, that is the delta H. Not equal to Q, sir. Not equal to Q. Because if it isn't, it is not a constant pressure. So important. Now, if the process is constant volume, now today actually start. This was old discussion, okay? Coming from the last day's class. So constant. Now, next. Achha, now, under constant volume, you take up. Achha, consider a constant volume process. This is better, right? Consider a constant volume process and again keep that restriction when the system. Achha. Keep this. Constant volume process. Then start first law. First law is a great resort. First law is a shelter. So first law is what, sir? I will apply the first law to that process. Is in the differential form. Always differential, encourage yourself. Differential and integration anytime, any moment. Don't jump into the integrated form. It's finite changes. PQ is du plus dw as you write. Then you know if you keep the provision for non-mechanical, right? Initially at least dw mechanical plus dw prime. I'm not writing. You know that is non-mechanical. Okay. Remember this is non-mechanical. You know once more I'm writing, but I will not write. Always you have to understand non-mechanical work. Prime. So what is this? Du. Happy. Du is du. It's difficult to write du as du. This is not difficult. Du is du. Plus dw mechanical is how much? PdV. I said PdV. Remember, if reversible. Say recall this. This is important for whole life. Whole life you remember this. dw about dw mechanical. Remember is basic relation, starting relation, defining relation is what? P external dv. Never ever forget. You start from that, then you will build up everything. I do that myself. P external, never drift from this. P external dv. This is the first principle. Then what it becomes PdV reversible. Any reversible on earth PdV. Okay, but for any reversible right here, reversible constant pressure. Achha, let's do this. Reversible. Keep it there. Don't have to make it clumsy. PdV. And also any reversible process. Right? Any reverse. I don't have to write this. Again, this is very helpful. dw mechanical. For example, follow this. Reversible any. Suppose isothermal. Reversible isothermal. What is the dw mechanical? PdV. You have to understand this. Understand. Irreversible isothermal? No, sir. No. Okay? Okay? It will be different. less than that, greater than expansion compression. So careful. So reversible, similarly adiabatic. So reversible, then okay, whatever, isothermal or adiabatic. So irreversible will not, okay. But DW mechanical, another way of looking this is always PdV. Reversible or irreversible. Now, this is not for irreversible, okay? Not always for irreversible, okay? Sometimes you understand. Is for both reversible and irreversible. It's surprising. For both reversible, if the process is for reversible, irreversible, constant pressure and constant volume. Processes. This, if you note, you will help yourself. Very easy. Repeat yourself. DW. Sir, any reversible PdV, sir? Any? Isothermal PdV. Adiabatic PdV. Constant pressure PdV. Constant, all. Reversible. Irreversible? Isothermal? Not so. No. Adiabatic? No. Now, this is the status. Here, DW is always PdV, irrespective of reversible and irreversible, if the process is constant pressure or constant volume. Any. Pressure or, and means, or constant volume. Okay. So, here, if you ask for constant pressure, what is the DW mechanical? So, PdV. Reversible process. If it is a reversible process, PdV, of course PdV because for this property. But if it is irreversible process, yes, still PdV because it is a constant pressure. Similarly, constant volume, yes, does not matter whether reversible or irreversible, PdV, and of course it's 0 because constant volume means no work. dV is 0. That is the constant here. So 0 means, both 0 means same, again same. Reversible, irreversible, same. Okay, and follows PdV as it. Oh, this, and another thing, I'm actually say, I tell you quickly how to follow this. PdV reversible isothermal is getter or expansion. PdV reversible expansion and irreversible expansion with ideal gas. N moles. It is PdV and irreversible is not PdV. Why? So follow. Why it is always PdV? Why it is not? It must be reversible to be PdV. For irreversible, it is less than PdV. Maybe 0, sir. Is expansion because again 0 pressure. Maximum degree of irreversibility, we don't know. We cannot define this. It is less for expansion. Work done by system. So, why this happens? Because isothermal and adiabatic are performed how? By working on the external pressure. Surrounding, there you change, say P minus dP, P minus 2 dP, etc. Or suddenly from say P1 to P2, abruptly. So there is the difference and work done. That's why it is changing with the reversible or irreversible. Isothermal, adiabatic similarly. As isothermal, adiabatic, we will discuss adiabatic later in details, but same. Means pressure are manipulated there. External pressure surroundings is manipulated there, there is provision there. Accordingly, we say reversible, finite driving force or infinitesimally small driving force. I start from P1, it can be P1 minus dP next step, or it can be. So, there is provision. So, PdV will work with the reversible. Okay. Okay. Now, irreversible, constant pressure, say constant pressure. No, you don't work there. P cannot be P minus dP or P minus delta P. It is a constant pressure process. P, don't touch that external pressure. That is the requirement of the process. So how shall I distinguish between reversible and irreversible there? So we distinguish by that in case of isothermal. How to distinguish now? It is constant pressure process. Do somewhere else. Thermostat, temperature. In one case, temperature is T1, plus T1 dt, T1 plus 2 dt, T1 plus 3 dt until T2. And another case, T1 directly to T. There reversibility and irreversibility. Another aspect of surrounding is the thermostat, heat interaction aspect. So don't try. So that's why no surprise that it will be same. And that's why you remember that drawing that I show you, PV, remember? That's good. Remember, that's why. See, expansion, physical thing, picture, mental picture. This is very useful and very powerful. Just not memorizing this relation. It is what? Constant pressure, reversible, remember? I said constant pressure reversible 1 to 2. And irreversible, what I did? I could not change it. Only said, I said, sir, dotted, sir, because non-equilibrium. But this work done is area under the curve. So, sir, reversible, who cares? Who cares? Who cares? The reversible or irreversible work done is same. So that's why dW is PTB, irrespective of reversible or, okay, for both reversible and irreversible. This part I inscribe in your heart, in your mind, that this never forget, okay? Many a time I'll ask you. Don't get floundered. Answer this, right? Smartly answer these questions, okay? For example, coming now. Now tell me, what shall I write? Du. Remember constant volume process. dW mechanical will be how much? dW mechanical will be how much? PdV. And is what? PdV, and then dV is 0. Plus dW prime. So what it becomes quickly? du plus dW prime. dq is, box this. This is the general relation. General relation. Note, again write at the end, at the beginning, at the end, at the middle, if necessary. Lest you should forget, because you don't know yourself well. You don't know how forgetful you are. You are not very sure. Why you write? At the end also. Or when volume is constant. Once more. So that you see here, and forget the previous steps. I talk constant volume. Happy? No. Next. Compare. Quickly compare. It helps you. It will help. Right. When, as I said, dW prime is 0. Common. Very common. Then what is? dq is du. Again under constant volume. Again dq is du. Okay. Under constant volume. Right. Or finite change for integrated form. This is differential form. Means infinitesimal. For finite changes, what is this? What's all right? For finite changes, what's all right here? Q. So practice now in the class. You are prepared, 50% preparation here. If you follow, you will feel like preparing yourself. Q is what will write? Yes, still the form Q to hollow, left hand side. Then what shall I write on the right hand side? Q and U. I am finite change, I am integrating. What I am doing, integrating. And left hand side, delta Q.
Not delta Q.
Q. And right hand side, delta U. Integration, you know what is the integration? This is a very fancy symbol. Integration. Very fancy symbol. And du, but dx, you know what is this? And if you put a limit, is what? x2 minus x1, people call it delta x. It is difficult. Dx, finite. Infinitesimal, finite. Differential, integrated. Whole class. This spectrum of classes, okay? All classes. Okay, very good. So Q is what? Don't have to ask books. Okay, I'll give you references today. I thought, excited. I didn't forget. I'll give you. Happy? So is it under constant volume also? Therefore, no. Therefore, I'm sorry. It's only coming from Siliguri, you know. So it is still under constant volume or constant pressure. This is okay, but when I'm integrating, it is still under constant volume or what? A conviction. So why not, sir? And that you argue, challenge, keep challenging the teacher. Compare for your satisfaction. Always compare. What I learned before. Compare. What I have already said with this. So what is your comment here? Heat interaction is what? What is the internal energy change? Heat interaction is what? See, change in. See why I say interaction is not necessarily equal to enthalpy change. If the process is not constant pressure, for example, constant volume. No, sir, it is not delta H anymore. Delta U. But careful. This sometimes a student have to forget. So only people know all this. Even books also, okay, heat means enthalpy. Bad. That screws up your concept. There is no hope of learning thermodynamics anymore if you think our heat interaction is delta H. And most of the times, I tell you why it is written. Most of the times it is a constant pressure process. You open to atmosphere. A reactor, open to atmosphere is a constant pressure. So often you come across. And as I said, non-mechanical work is not involved more commonly than not. Why? Who will actually involve electrochemical work or surface work? They are special. So when they are absent. So these two are, if satisfied, then always. But you should know the restriction is there. So yeah, right, all set. So compare quickly. What you learned here is what is this? You learned here from here. Here, compare here. dq is tell me. Because previously is what? dH plus dw prime is what? Again write. Again from this you write. dq is dH. And what is the corresponding? Q is delta H. And right, and when, tell me, when under constant, tell me, constant pressure, tell me, this is a constant pressure, this is constant pressure, that side, constant volume this side, under constant pressure process. Right, when dw prime is 0, you can write here once more. Okay, this is over. This is the initial. Quickly, now take up quickly. Then I will give you something references. CB start. What is CB next? Now again, too far. Huh? Oh, okay. Now start. Don't worry. So remove this. Who cares about this? Start. Start. CB I am writing. Heat capacity. CB. CB is what? By definition, tell me. Del Q by del T at constant volume. Del Q by del T at constant. Sukanto. You must be Sukanto. Okay. Del Q by del T at constant volume. Then I am writing del Q at constant volume. What I can write? Del Q at constant volume is nothing but du a moment ago. Here. So del U as good as writing del U by del T at constant. Why partial derivative? Why? Remember, any constant means partial. No constant, total. Dy dx. When there is a constant, like constant z, del y del x. This I said. So this gives you what? Or du is Cb dt. Under, when it is valid, under constant volume. Happy? And also, since this is CB, remember you should be careful. CB is what? Extensive. Oh, I forgot, today is the assignment day. Assignment, okay? You are prepared though with assignment? I have to take up, I have to stop this. I forgot actually. It cannot be. No? It has to be discussed and completed and okay, removed from the list under constant volume. Okay, let us finish this. No problem. No hurry. Many things on hand. So this is okay. Du is CBDT. For I am writing since CB is lowercase. Lowercase means what? Lowercase, yes. You tell me Nidjar. It must be Nidjar. Lowercase CB means for this internal energy change du valid for how many moles? Lowercase cv means intensive, means 1 mole. Molar, remember, this is molar change. Oh, this is molar, this is molar. 1 mole, 1 mole. For 1 mole, right? For 1 mole. This is very important. And if it is n mole system, n cv dt for n moles. So let us see how much you follow. I will keep asking questions and teasing you until you are all serious. Start. We start from this. See, you have started this or that. For which system? This is a constant. Yes, very good. Which system? System is what? Huh? Volume process. System is what? Gas, liquid, solid, ideal gas? Ideal gas. Anyone has any other answer? This actually chronic problem. Ideal gas, sir. Take certain ideal gas. Oh, you are written something. Oh, must be ideal. Ideal or what? Ideal, sir. Why I have used the ideality? I have written a simple heat capacity definition, an innocent equation. Is it not valid for solid iron? This relation is invalid for iron. This piece of wood, invalid. For my body, invalid. For this glass, invalid. So this is always true. When I will use ideal gas, then I will let you know. Or you will have, you also PV not I am using. Sir, you are using ideal gas equation. Not non-ideal, sir. It would be then van der Waals, etc. Solid, liquid, very complicated. Careful. So, what is to be lesson here? Careful. All careful. Each step. So, I could have avoided asking these questions. Then I would have finished actually. Okay, 2 times or 3 times this marks, this portion of syllabus. No, sir. No. So far, no ideality. All systems, solid, liquid, gas. This is liquid under constant volume. Where is it ideal gas here? Anywhere? Ideal gas. Anywhere, starting from here to this, is anywhere ideal gas? PdB. If I expand, this will increase. The volume will increase. Constant pressure heating. For ideal gas, you know, constant pressure, I said constant pressure for solid also, very easy. So heat and this expand against what? Constant pressure. What is the pressure, sir? Gas has pressure, external pressure. Atmosphere against the atmosphere is expanding. So everyone. Oh, that's the beauty. That's the usefulness. So nowhere. I have written already for what system? Constant pressure, everything. The enthalpy of not only ideal gas. This piece of chalk enthalpy is what? What else I would say? Now, its internal energy plus PB energy, the last date. PB means pressure. Solid don't have its own pressure. Gases have. So, exposed to. This atmospheric pressure is 1. P is 1 atmosphere. B is the volume, this volume. Why ask for a cylindrical, suppose? Get. CC, the CC atmosphere. But suppose it is joule. Typical unit of energy is joule. PB is energy. So joule, CC atmosphere means, 1 liter atmosphere is how I've given the relation 101.3 joule. So CC atmosphere convert into joule. So they all joules H is coming out. So is it restricted to ideal gas? Why, sir? Then you don't have to study thermodynamics. If it is all for ideal gas, then you don't have to. You have to handle actually steel making reactions, iron making reactions, okay, all synthesis. You have to consider phase transformation, phase equilibrium, phase diagram, electrochemical cell, surface phenomena, so many things. So similar, please. Where I am. So this is for N moles. I have not written ideal gas. Ever. Ideal gas we will consider, okay, for discussion, okay, because we learn this actually. Because some gases are actually working substance, for example, cycles, steam engine cycles, water vapor, superheated, so gas. but not restricted to. So anyway, but I am not giving the restriction. You follow. So where is the restriction, sir? Where you have said that is ideal gas? Where is ideality that you have applied? This is the way. So what I wanted to tell you. So you see, these are corresponding. So you see, this you understood this. What I suddenly wanted to tell you. It's okay. All okay. What else? Yeah. Okay. Oh, this is again. This is here. Oh, all right. Good, very good. CB. Can I remove this? Remove, eh? It's better I remove, na? You don't like to see this. Okay, because again I will ask question from this. So CB. Okay, for n moles of any substance. In case you have difficulty, write this any substance. Now Cp likewise, attempt likewise. Oh, this is valid under when? Under, tell me this relation valid under so iron. Anytime you want to drift from ideal gas, go to not only real gas, go to iron. Metallurgist will consider iron. Iron is a great issue in metallurgy. So iron, sir, iron solids piece, a piece of iron, sir. What will do? Do this, no problem. Under constant, also volume heating a solid under constant is difficult. The liquid you may consider, or for constant pressure you will consider this. Come here, okay? Then Cp. Start. Next, again Cp is what? Del Q. Tell me, del Q by del T. Again tell me, del Q by del T under constant pressure. You know, this I always give. So much. Then what shall I write? Tell me, del Q under constant pressure is del H by del T under constant. See how many arguments you can make in one line, one segment of a line. How many? See, I am bringing out this argument because I myself asked myself these questions. Then I got the answers myself. I brought out the answers. That's why then I share this with my students. Here also, see here also you could argue, or here for that matter. Here dq is dH, constant pressure. You agree? You agree? But is it dq is dH under constant pressure necessarily? You could argue. What you could argue? No, sir, dq is not necessarily under constant pressure. Under constant pressure, still not, sir. It is plus dw prime, sir. Now heat capacity of what I am thinking of a substance, pure substance, solid, liquid, gas. So there is no question of any non-mechanical work there. Okay, there is no question of non-mechanical. So implied that there is no heat capacity definition. There is no question of any non-mechanical. Non-mechanical work comes when there is a chemical reaction and electrochemical cell. Or surface work. Why surface? We don't consider here surface. Because actually surface is not tiny particles out, okay? So there is surface area is okay important, predominant. Don't worry. So that's why. So if you can argue, if one argues, why such dq is not necessary, it one student could have argued. I made such students in the second year class, previous years. Not currently, maybe 10 years, 20 years ago. Yes, student could ask. So dq not sir, always sir. When? Why is that, sir? How do you know? How do you consider write that? Then actually heat capacity for say water, aluminum, nitrogen. So how do you get a non-mechanical work there? So automatically ruled out. Happy though. So remember some argument, but all I don't write because it is not possible to write so many things. It is okay. It is understood. Is okay. Then what shall I write? Or tell me. Or dH is Cp dt. Good boy. Under constant pressure, write that. So similarly, paraphrase this. Under constant pressure. This is very good. Then it is okay under constant. Then it is for 1 mole, and for 1 mole of the system. I am writing 1 mole of the system right here. The system or substance. Species, material, metal is NCP/dt for n moles. Happy to over. This is over. All set? Okay, CPUs. No problem. Okay, but one point I am giving you in advance. Note one point. If you don't understand now, don't worry. But I will explain. One point in advance. Advance because I will prove later on. What is this? For ideal gas system, and now I am talking something. I have spelled out ideal gas. Ideal gas. Now I am right also. For ideal gas, I have not mentioned here. From the coming from through the class and starting this lecture, I have never used the term ideal gas. For ideal gas, note for one ideal gas, du is NCBDT and dH is NCPDT. Doesn't have to be constant volume or constant pressure. No restriction for any process, irrespective of. Note down, irrespective of any process like any process, e.g. constant pressure, constant volume, isothermal, adiabatic. Don't care. Why I will explain, but I can say just touch upon this. And for ideal gas, these two gentlemen is function of temperature alone. They don't care. This I'll explain later, better way. The function for ideal gas is a function of temperature alone. So don't care. Constant pressure, constant volume, anything. So it's rigid. So see the distinguish. Any system, ideal gas. Over quickly, very quickly. Take the assignment. No. I'm sorry. First I give the references, because I forgot to. Please take down the references. References or say recommended reading. Okay, references. Recommended study reading. You may read these references. I'm giving you one by one. Okay, write this one. Introduction to thermodynamics of previously called metals, but nowadays it has been changed by the author as talks. Okay, good, very good. Many talks of materials. You may consider this may be currently 4th edition or above. Okay, so second edition will do, but I don't know, second edition or above, or later, or above. Okay, second or third or fourth. Okay, so this is second is physical chemistry of metals. You remove this. This is okay. So can I remove? Thank you. Clean all these things. Physical chemistry of metals by by what? I forgot the Dr. Gaskell, first one. Second is Darkin and Gary. You have actually number of copies of this in the library. Number of copies, you can buy one copy yourself for your actually acquisition. You can have. This is Darkin. You will get a few copies only, not many. But I will give you handout. In fact, today I will give you handout. What I will teach, heat capacity, I brought one handout. A number of pages it runs, but I will give you today. Handout, give reading material, the books that you cannot get hold of, because not many copies available around. So I will give you handout. No dearth of reading material. And more importantly, you follow my class. The best way to learn this subject, if I may say so. Third is what? The principles of chemical equilibrium. By K. Denbigh. K. Denbigh. I tell you what, I may forget. He is a metallurgist. You will be happy to know. They are metallurgists, great metallurgist. And this is a great chemist. And this is called a classical text. This is in the chemistry students should actually read this. Fourth is thermodynamics. Thermodynamics by Lewis and Randall. This is also third edition also, but one edition is available only. Lewis and Randall, which is later edited by what? Pitzer and Brewer. First of all, I said Lewis himself is a great pioneer in thermodynamics. You know, Lewis acid, Lewis base, this Lewis. After Gibbs, he is actually one of the main architects in actually building thermodynamics. Nance is another great name. Haber is still another Nobel laureate. Haber is a Nobel laureate in chemistry. So great names. But Lewis, okay, these four books. By coincidence, I will give you the handout from this book. This book you will not probably get. I'm afraid. You may get one copy maybe, but cannot be taken out from the library. So I will give you copy. Always I am available. What is reading materials are available, I will supply them. Okay, in sufficient quantity. Don't worry. So recommended reading over. Okay, this is what? This is they are also chemist, metallurgist. Okay, good. What else? Oh, assignment. Next is assignment. Next take up assignment 1. That is due today. Maybe the date I made a mistake. Na? It didn't mention. Na? 21 I wrote. Na? Have you noted the date? Due date? Huh? What? Huh?
Moving on a university isolated system.
Huh?
But can be considered as an
Now that about the assignment. Coming from the assignment, I will discuss. Assignment I will discuss. Okay. Have you tried to? You are not feeling good? That you can, but are you not feeling good here? Feeling good here, this environment? Okay, because assignment discussion. No. Oh, room to always available. So now I will discuss then. Bring this. Okay. Remember, this is due date. Due date I made a mistake. Have you noted? Due date what I wrote? What is the due date I wrote? See the show me the assignment page. Assignment, you don't have this piece of paper? You don't bring assignment? No, what are you showing me? I don't do this now. Assignment. I gave you actually the handout. Handout, you have everyone local?
Yes, sir, it is it.
Turn that page. Okay, open. It should be right. See, keep this actually with you. Okay, make a. Now this you see for yourself. What is the date I wrote?
20th April 2021.
21. It is 21. So you could have mentioned. Okay, I saw today only. 23. So I will ask you questions. Okay, if you don't actually, then I will skip this. Remember, I am very strict. First of all, if you don't know me to be strict, then ask your workers, seniors, whether this gentleman is strict. Okay, how he feels when you are. Now I will first ask you. I will first ask you how many students. I'm coming to this. I will first ask you how many students have solved this problem. See, this is the paper. This runs 2 pages. I actually wrote at the top that last problem is excluded, is withdrawn. So only 4 problems. This is actually the rudimentary problems, the simplest of everything. You will not get so simple questions in the subsequent assignments. So, how many? Raise your hands. Who have solved this? Try it. Good. I'm happy. I'm happy. 3, 4, 5, 6. Satisfactory. Satisfactory. Oh, you are half-hearted. You are not sure. Your name is what? Eh?
Sovi Sadhubai.
Sobi. 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 Ayush, did you try? Huh? Did you try this assignment? Did try? Okay. At least some of them you have tried. Problem 1, start. Don't waste time. You go through this. First is you get your answers. Any questions, you let me know. Address so the others should hear also. The metallurgical engineering department means you have to understand this metallurgical engineering department I have mentioned. Okay. So what is the system? Keep reading, and so this part is over. This is all over. So start fresh. Can I remove? Can I remove? 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 Actually, due date, you note this. Due date, you note 22. For 22, actually, it was actually already, okay, it was within that holidays actually. So 29, okay. So you can guess that it will be 29. Start. This is the simplest problem sheet. And one other thing I should suggest, you bring out copies, hard copies. No, best, and actually collect them, the good collection. The whole life, Rahul Sarkar is now IIT Kanpur. I should not talk all these things, okay, informal talks. He was asking, actually, he said asking some questions for his interview for the assistant professor. Also for PhD from this department, and then PhD from University of Utah. Master degree from IIT Kanpur, IIT Bombay. So when you interview, he is asking us, why is your notes? You follow, he was referring some book. Why are you referring? What I taught. Then he was, I misplaced. Oh, I don't have. Then no hope. And other students, he never say, I will never lose this property. Still with us. 20 years later, he says, still we preserve. So what are you doing? So bring out copies. One copy. How much it takes? 1 rupee or 2 rupees maximum, no? Taking out this in hard copies. 2 rupees maybe. And 7, say 8, 16 rupees you have to spend this. If you have 16 rupees, you don't have, you can take from me. If you don't have 16 rupees, okay? And another thing is this. These are all full stocks, okay? Start. 1. Question is what? Write whether the following system, I have to write this, write if the following systems go slow are open, closed or isolated. Answer. Start. One by one. Take up. Metallurgical. D. You have to give a D. Means this department. What is your answer? Open system. Open system. Very good. Open. But I will ask actually now selectively later. But okay, initially maybe go together. Second, quickly is human body. What? Open system. Good. Third, earth, the earth, open. Because energy comes, mass, okay, exchange between earth and other sun and etc. Mass transfer is possible. Earth, water vapor is going, earth, mass transfer. Oh, open, to be open, mass transfer, okay. See, from this, okay, things actually, so meteor is falling
That
actually.
means the ocean is evaporating.
Ocean?
Ocean is evaporating the water.
Now the water goes to actually, that is also in the part of this actually.
Atmosphere to
Still in the atmosphere, earth atmosphere, you are right. Earth atmosphere. Closed system actually, you see some materials also sometimes come from actually, from extraterrestrial things, okay. Other examples you get. From the outer space things may come, okay, see, open, okay, fourth, maybe. Okay, fourth is what? Badly insulated thermoplasm. What it would be? Badly insulated? This is easy that I am not discussing. Okay, fifth is a fully insulated. Fully insulated thermoplasm. Fully insulated thermoplasm. What is this? Next is what? Pressure cooker. Heating on a gas flame. A pressure cooker heating on a no, very difficult 10 minutes outside, 10 minutes, then you may get in. 10 minutes outside, 10 minutes, no talk, don't disturb, 10 minutes on a gas flame. Acha, well, hello, 5 minutes, there, 5 minutes, okay. I have actually used 5 minutes outside, not here, not before me. A pressure cooker heating on a gas flame will be what? Pressure cooker itself is a closed system. But when it releases steam, then it becomes actual. So it depends. So if you write this, that is open system. Closed. No, you may not. Ask him how long after. Closed. But open when? But open system when? When the valve is released. When steam is released. 10 minutes, another 5 minutes for this, okay, another 5 minutes, 10 minutes. You come after 5 minutes, he will wait. 5 minutes, 300 seconds, you call 600 seconds, you will not be allowed. Go away from this, 600. No words, okay, no argument. 5 minutes, okay, 5 minutes. 300 seconds, you have forgotten in case. So 300 seconds, and you 600 from now. Closed but open system when the steam is released. Quickly, get on. Move on. Then comes 3 figures. Remove this. The figures, you follow this. First figure, figure 1. FeO, FeO, FeO solid, CO gas. This chamber is filled with CO gas and FeO solid is sitting there. And this is this figure 1. Hydrogen gas, no? Hydrogen gas. So figure 1. Figure 2 is what? Similar, but only this way. You draw this again. FeO solid, hydrogen gas. Only this. You have to distinguish if there is anything to distinguish. And figure 3 is what? This. What is sitting here? In a container, FeO solid, and a stream of hydrogen is going into the reactor and leaving. This is a figure 3 situation. One thing to be noted here, the reaction involved in figures 1, 2 and 3 is a reactive system. These three are reactive system. In 1 3 is FeO solid plus hydrogen gas goes to Fe solid plus H2O gas. H2 gas. This is given to you. So this is a hello. Get in. So so these are reactive systems. So figure 1, these are chemical reactive systems. Okay. So these are if you might use this term, reactive chemical reaction system. What is the term? Chemical reaction systems. So now tell me one by one. So take up. What is the problem? Problem is 7. Figure 1. What is your idea? What type of system? Isolated. Because this is isolation. Reaction all very good. Nine, 8. Figure 2 is what system? Because this reaction generates heat and heat will be released. Okay, so it will not be confined within the system, so it will be coming out to the surroundings. Okay, so there is an isolation, so closed system, but no mass is coming out. Closed system. Figure 3, open system. Okay, see there is also heat will occur open system. What else? All over? Okay, all over. Of course, problem 1. Problem 2. Start. Anyone? Any queries? Doubt? Somo? No problem. Okay. Yes, Somo. Yes, Somo. And you are? Vidyut. Okay. It will take time. Vidyut. Okay. Problem 2. Problem 2 now. Write whether the followings are intensive or extensive properties. Good. Quickly. Remove this. One by one. Molar volume. Molar You are Advai. Your name is Advai? Advetri. Advetri? Intensive. Everyone agree? You are actually Devopo. Your name is? No. What?
Sanjana.
Sanjana. No. Another name is first yesterday. Who present? No. No. Another came.
Sahela.
No.
Unutua.
Unnotua. Unnotua is missing today. Molar volume is intensive. Second, good. I forgot the name. By the way, what's the name? You said what's the name? Sanjana. Sanjana. Next concentration. Acha, molar volume is intensive. Why? Why Sanjana? Molar volume is intensive. People are agreeing. Students are agreeing. What is the? Can you justify why molar volume is intensive? How to judge whether it is intensive or extensive? No. There is a trick. What is that? You know, 5 minutes. That's why you have 5 minutes. Not for without reason. That's why you don't understand. Careful. Molar volume is, follow Sanjana, moles, volume per mole. Volume of 1 mole of any substance. Volume per mole. Now, this moles is extensive and this is, volume is what? Volume is what, Sanjana? Volume. Intensive. No, extensive. So, two extensive, ratio of two extensive property leads to intensive. Concentration is mass per volume. Similarly, remember molar volume. Okay, very good. Mass per volume, intensive. Okay, intensive. Third, quick. Heat capacity. I'll be happy if anyone. So let us see. You answer. You answer here, Amartya. Heat capacity. What is your idea? Heat capacity is good. Any other form is intensive? Is extensive, but can it be intensive if I just modify a little bit? No. Molar. It is for how many moles? Why extensive? Depends upon the size. So n moles. N getter. Total heat capacity, that's what I say. Total. As defined from molar. 1 mole. So take big size. You may take big size. But does not matter. 1 mole I am interested. You take small size, I will scale up to 1. You take big size, I will scale down to 1. But when I take the absolute this size, means depends upon this. That's the total heat capacity, n moles. Everyone is okay? So it is extensive. Note, molar heat capacity is intensive. Hey, alert me 10 minutes today. 10 minutes. 10 minutes before. Instead of 5 minutes, 10 minutes before. Huh? Good boy. Fourth is what, Baba? Fourth is specific surface area. It is interesting. It is actually, first of all, you should know what is specific surface area. It is surface area per unit volume. First, like that. Surface area per volume. This is specific surface area. Now, suppose you consider spherical object, spherical. Then what is the surface area? Tell me. 4, 5, spherical. For spherical, volume is for spherical object. It must have some shape. So what it is? 3 by r or 6 by d, you often say 6 by d. But then if the r diameter increases, this gentleman changes, small, bigger. So this must be extensive. It is not intensive. Depends. R is actually extensive. Radius, lengths are increasing. Volume, length, all extensive. How much you are considering? So this much. Okay, this much length or this much length. Similarly, radius. So what is the answer? Is then it is what I should say, extensive. Extensive. Then is fifth. Fifth is what? Electrical resistivity from high school. Hey, hello, your name is what? Your name? Huh? Rishabh. Oh, okay. Rishabh will be, okay. Rishabh, resistivity, electrical resistivity is intensive or extensive? Remember, R is rho into L by A. R is rho. Is a resistance, resistivity, length by cross-sectional area. So this is property. Property does not know how much it is. Density does not know. Small size or large size. Correct answer. Sure. Actually, like the sixth, don't worry. There is some debate here, debatable. So don't worry. 1 by? Which is 1 by R? I am asking resistivity itself. Question is resistivity, not A and A. Question on this is encircle. This is your resistivity. Okay, very good. Over and drop that last one. That's it. Problem 3. Drop the last one. It's okay. Drop because there is some debate. It depends actually. Okay, debatable issues. Problem 3. This is about projection. Has anyone done this? I will be happy if any of you done the projection. Oh, good, very good, Nirjor. Congratulations. Why it is difficult? It is the easiest. It is easier than what we did in the class. Isothermal. Easier. So what is the question? I am writing in short. Give the projections of the given constant volume path on PVT surface onto the PT, VT and PV. This I taught you. Why you need to attempt? Easy. So start. Suppose this is the path, given path. This is the given path. You have to draw the projections. So on the first try, VT plane. This is on the PVT surface here. Yeah, remember PVT surface? For ideal gas supposing, easy to equation of state. PB is RT, nRT. So here it is like this, like this. So let us drop the projections. How to drop projection on BT means parallel to P, coming down. So vertically. These are actually construction line. Don't actually lightly draw lightly. And likewise, suppose you choose one volume. Suppose this is your chosen volume. Constant volume, so some volume must be given. Otherwise, you don't know. Since constant volume, this is the chosen volume, then this is actually your this is the volume, and this is the projection. So write 1 to 2. You write 1 to 2. Bold line, and give double arrow to distinguish from the single arrow. This is the projection. Now you see, you also note here, another student actually, note here, now what is the pressure corresponding, this is volume temperature, so this is the volume, so temperatures get from here, how will get parallel to volume. This is the one temperature, this is T1, yes, please specify the state, perhaps it is given, it is not, right here. P1, state 1 is T1, state 2 is T2, since constant volume. So he's happy, one projection is down, okay, you try yourself, okay, other projection, you try yourself while I do myself. So note here, this is what temperature, this is T1, this is T2, no doubt. Sanjana is okay, T1, T2. Then you do what? You what actually on the PT plane. Since this is a PT plane, how you get this on the PT plane? Actually, before the PT, I am taking the PV easier. Easier is our PV. Again, constant volume. So this will be constant means vertical. Okay? Do this construction line. Go along the P axis, parallel to P axis, a construction line. This is the V, and what are the, you actually now on the PB, what should be done? Parallel to T, means horizontal. So 1. You get here. You get here, okay? Sorry, get here. And again, here parallel. Well, this should be actually parallel. Parallel to what? Since on the PB, parallel to T. T means horizontal line. So let me draw construction line. So it hits which one? This one as where? This is the volume. Hits here and hits here. These two hits here. Okay. This hits here. What is this? This hits. This is your 1 to 1. This is a 2. This is what? P1. If you want interested, this is P1. This is the P2 in this scale, P2. And this is the answer. Projection. Double arrow. Okay? So 2 projection down, 3rd projection, how to do this? On the parallel to V. So do one thing. See here T1, T2 is there. So again this should actually, so let me draw this class here. T1. Maybe this is actually, this is not necessarily this one. Okay, this is here. So draw. And how will you get this? On the PT means parallel to V. What is the V? This. So this will 1 hits here. And 2, draw this. Draw this. 2 hits there. So these 2 connected, then what will do? This 1 and 2, this is 1. 2, how do you get this? Connect. What is the connection? Straight line, sir. Straight line. If volume is constant, pressure and temperature, linear relation. PV is RT. PV is nRT. So PV is RT. If V is constant, P is proportional to T, means straight line. Straight line. This is the straight line is, okay, is work. These are the answers, 1, 2. This is the projection. So you write here, okay, you see, what is this? This is actually your T1, T2, T1, T2. Thank you. Next one. So you do yourself, try yourself. Try yourself. Next one is maybe interesting. Problem 4. Any question? You don't. You follow the class you follow first, and then you'll get this. Okay. So. Okay. Problem 4. Or you may come later, in case problem 4. I'll help you, don't worry. But first of all, you must help yourself. Help yourself first. P. Okay. This is your cycle. This is cycle actually. 1 to 2, 2 to 3 vertical, and 1 to 3 horizontal. This is your cycle. Or arrow, don't give arrow. Arrow will be given later. 1, 2, 3. What are the, yes, tell this, P1, V1. This is P2, V2. This is what, guess? This is what? V2 same, P3. Or P3, V3 generally speaking, but you know, V3 and V2 are same. Likewise, P1 and P3 same. Okay, but don't worry. Give this. Hello, yes, you are actually now enjoying. Okay, okay. This yes, Amartya, tell us. First one, A. Check with the following statements. Figure what? Figure what? Figure 5. This is figure 4, na? What is this? Figure 4. This is figure 4. Figure 5.
There was a kind of a plane there is kind of representing all the 3x. What does that plane represent?
Plane representing? Is it BT plane? BT plane?
No, there is a plane passing the line that is running on the 3x.
P axis, B axis, and T axis. PBT plane. Okay, you have to attend the class. Actually, no, that will be helpful. This space. This is the PBRT. Here on this is PBRT. This is also plane. PBT plane is a plane, and this is also plane. And this is a plane. What is the PBT plane? This plane. What is the equation of this plane? PB is RT. If is one more. And this plane goes where? Infinity, all direction. Here you have a line, curve, path on this PBT plane. Okay, the class go to the class isothermal, constant volume, constant pressure, whatever. Then you do the projection here on this plane, on that plane, and on this plane. This is the task. Okay, you follow this. Actually, you can do your way, no problem. Okay, but answer will be same. Okay. So first, course, check the following answers. Check the following statements. Check whether the are true or false. Start. A. Delta F 1 to 2 is delta F 1 to 3 plus delta F. Hey, don't discuss. Don't discuss. Okay? You have discussed before. Okay, now we should keep silent and follow. And you think yourself. I will ask actually, individually. Hey, what is? Don't discuss. Don't take help of others. Yes, you try. You try. Okay. Here. This delta F 1 to 2, 1 to 3 plus delta. Achha, when I have written delta F and next time I will write delta F prime means you understand. F is a state property. Okay. Devapam, please tell me whether it's correct or wrong. False. Now Devapam will answer. What is the reason? Achha, 1 to 3. No, if it was 3 to 2, delta F 3 to 2 would be correct. 1 to 3, 3 to 2 would be correct. It is state property. Correct. Then you think it is correct, but then so change, follow, change. Okay, you said what? Sukalan? Correct or wrong? Yes. True or false? False. False. See, 1 2 3 1 2 3 see 1 to 2 1 to 2 as good as 1 to 3 plus 3 to 2 3 to 2 but it is not 3 to 2 2 to 3 so classes if it were 3 to 2 then correct statement repeat 1 to 3 3 to 2 means 1 to 2 why I tell you follow me this is how was right false easy way to do this follow 1 to 2 means what best way f2 minus f1 nothing like that oh sir state functions are very good sir path function cycle many okay see scattered thinking no jumbling up delta x x2 minus x1 come on and state property state means well defined it cannot be changed by whichever I reach suppose this is the state whichever this way I come or this way I come or I go out and come back to the same state all properties are same this state is defined by this okay whichever way so what is this easy way is f2 minus f1 this is what tell me 1 to 3 initial to final so final minus initial f3 minus f1 plus it is what f2 minus f2 to 3 f3 minus f2 does it cancel does it give this so is not when it would be correct if it were f2 minus f3 f2 minus f3 would be correct that means easy way now easy way you don't have to write also you see this way this to this to this means this to this again try another one this to this alternatively this to this alternatively what this to this plus this to this you are starting one step starting final here two step starting intermediate final same happy to okay be smart okay this is the next one is okay so it's not false b is what delta f prime quickly this is the last one quickly delta f prime 1 to 3 plus delta f prime 2 to 3 3 to 2 oh I have changed now second problem let us see he what you answer Somo Babu
Sir, it's false.
false good false why hey hello see why don't you discuss this over telephone while home why don't you do this that time you are doing something else watching movies you are thinking this is the best time keep silent give respect to the class and to the teacher no talk absolutely your time is over discussion I didn't actually ask you actually don't discuss but don't copy others you may discuss and put your heads together okay but on small things or on only part of the things or for complicated issues but don't actually copy from others you are doing the same thing yes
F prime is a path function.
yeah, but see it is 1 to 3 3 to that actually see tell me yes Deopam again 1 to 3 3 to 2 again see 1 to 3 3 to 2 and this side 1 to 2 are they same now you should know no why not EPSC why yes if not why not f prime first of all prime is path function f prime is a path function prime denotes path function no like walk and eat and here f is state function this is well known it is written here in the question maybe I don't know don't worry now tell me now this is okay why it is not true Deopam it is true or false your time is over it is true or false
False.
why false
Because it is dependent on path. Means,
independent of path
it's a dependent on path.
The path function should be dependent on path. I don't argue.
So if 1 and 2 goes through another one, and 1 and 3 goes through another path, and 3 and 2 goes through another path, then the path are not the same.
No, but terminal points are not enough. Having the same terminal points may not, is not enough for path function, because it depends on path. Which way you are reaching, from same initial to same final you may go, but which way, which path? You are going to say this thing? Okay, so, follow. Yes, follow. Suppose this is the work function. Suppose 1, 2, 3, 3, 2, 2. Take an example. Easy. 1, 2, 3, 3, 2, 2 is how much? The work. And 1, 2, 3 is also 1 to 2. Work. What is the work? You know? Area. I will not sketch here. I will not disturb this. Area. I want to. This part is removed. Remove also. Quickly. Forever. This path function. Sorry. I just see. Once more, draw this. 1 to 2, 2 to 3, 1 to 2, 1 to 2, another is 1 to 3. See, 1 to 2 both cases. Then you would say 1 to 2, delta will be same for state function. But path function is what? No, path dependent, sir. Path. So don't. Doesn't have to be same. For example, work, if it is work, what is this? Work is area. P I go to work, PV. Area under the, what is area under this curve? Draw this line. Only 1 to 2. 1 to 2. No, this is the area. And what is 1 to or 3? This is 3. 1 to 3 and 3 to 2. Good. 1 to 3, 3 to 2 is the area. So this part area and this part area. Vertical line, no area. So this will be additional. Is okay? So confused. So see, you know, path function is this. Path dependent. No use. Most of the things no use. This. When you answer this, that's why assignment. That's why you should come prepared with the assignment. This actually leaves a bad notion that you are not taking seriously these things. And I am shouting all the time. Same thing I am repeating. But some of the students good. Very good. This is okay, fine. Next is what? Next is what? Oh, AB. Can I remove all these things? C. Quickly, you can do yourself. Rest you can do yourself. Now let me quickly. I'm not explaining. You check this. I'm quickly moving. Delta F 2 to 1 plus minus rather. Minus. I've used minus now. No problem. You take this as plus. Now they have some of the students are following very nicely. 2 to 3, 3 to 1. 3 same. Out. 2 to 3, 3 to 1. 3 same. Out. 2 to 1 finally. 2 to 1 and 2 to 1 here. Okay? Means same statement because it is state property. D is what? Oh, this is a good question. Delta F 1 to 2 reversible is delta F 1 to 2 irreversible. Yes, let us see. Your name I just now forget, so don't mind. Vidut will tell us. Is correct? Delta F 1 to 2? True. Why? So who cares? Reversible, irreversible, state property. Path independent means reversibility or irreversibility gone. No difference, sir. You go anywhere, but irreversible path is not shown. So it is advised you show your conventional irreversible path. How you show irreversibly? Let us see one of them. Acha, here need your 1 to 2. Question about 1 to 2. Go. 1 to 2. What is the question? Question I am not giving yet. This is the question. 1 to 2. So reversible is given, irreversible is not given. Can you tell me how to draw the irreversible? Irreversibly. Dotted. Irreversible is dotted. Or you can consider, okay, why take help of it? Yes, sir, a dotted here. Like say, remember this way. This is also possible. 1 to 2, 1 C, et 1, 2, 3, 1, 4 maybe. Irreversible connection. Happy? So does not matter, sir. 1 to 2 anyhow we go. Means again F2 state function no. E. Delta F prime, answer this. Some of you. Be prepared. Irreversible. Oh, reversible. Sorry. Reversible. Since I have already sketched for your convenience, tell me, yes, will you tell? Amarto will tell. Acha, you tell. Adri, is correct. So what what will be answer? False. Good. Very good. Path. That's 1 to 2 does not matter, sir. Initial final state does not matter in case of path function, sir. Which way you have reached from the same initial to same final. That's not enough. But for state function, enough. I don't care which path. Which path. Good. So what is the answer here? It is true. This is because F prime is a path property. Or note here, F prime is a path property. Okay. So for example, again a waveform, can you take this as area? You since you have now understood area. So this is 1 to 2, reversible, left hand side. What is the area? Area on the curve. And then what is the area here? Below the vertical line, no. Different. Is not false. F. Now, question 2 and 3. Can I remove all these things? Over 2. They are all closed. Find delta F cycle. Find one, two, three. How much? Yes, Sukolan? Yes, can you tell me why? Any other? Any other way? Yes, answer correct. Over. Cyclic, sir.
Initial and final.
You take my okay advice. What is that? I don't know what is happening in intermediate. F1 minus. Anyhow, cyclic 1, 2, 3, 1, sir, no change. I return. I went to Gorihat and came back right here. What is the state change? Okay. Change in the state property? 0. Good, very good. Okay. Third is what? Find. Oh, sir, 0. Okay, answer is 0. Find delta a prime cycle. It is interesting. 1, 2, 3, 1. Again cycle. New cyclic. Now what is this answer? Again, Sukolan will be able to answer. Not equal to 0. Good answer. That is very good answer. The first answer is because what? Now what is the any statement will do also. You don't have to give the numerical value. What is statement? What it will be? Area enclosed by the cycle. Area enclosed. This is the answer. I tell you why. You want to know. Answer is area enclosed within the cycle. What is the cycle? Tell me. The way written 1, 2, 3. Will you write 1, 2, 3 cycle? Will you write 1, 2, 3 cycle? Yes. Then it will be cycle. This is the answer. So what is that? Yes, you tell us. Okay. Area enclosed means an answer. Plus or minus? Plus or minus? Note this important issue. If it is a clockwise cycle, see the cycle. Clockwise positive. If it is anti-clockwise negative. Work. This you will understand later. Okay. So is not 0. What is the area? Area enclosed is not 0. What is the area? How will you get this? Yes. How will you get this area enclosed? As you can do. You tell us. How will you get the area enclosed? Every. The enclosed. How will you get this? Quickly. See the figure. See the cycle. Looks like a quadrilateral or circle or triangle. Cycle. Triangle has formed a triangle. Enclosed means area of the triangle. What type of triangle it is? Right angle triangle. Half base altitude. Very easy. Half base. Base is what? What is this? This is V3 minus V1. Altitude this much. This is P3 minus P2, etc. Easy. Non-zero. Okay. Note. Clockwise. Very interesting. That means what type of cycle it is? It is what type of cycle? 1, 2, 3, 1. 1, 2, 3. Which cycle? Means negative. Now you see, you want to be more satisfied, I tell you. Quickly I tell you. Follow me. 1 to 2. What is the area under the curve? Is what is some value, numerical value. Positive or negative? This is an expansion. See, expansion. This volume to this volume, expansion positive. This is 0. Does not matter. This is incidentally negative has been greater than the positive. So negative and makes sense. So this is actually a what type of cycle? Anti-clockwise cycle. Makes sense. This is the answer. All over. You those who didn't attempt, try to attempt. Okay, yourself going home and be confident in this, because this will actually the basic assignment. Okay. First assignment. This is over. Then how much time is? 10 minutes left. 5 minutes. Oh, that's holiday day. I could not start actually. Anyway, thank you very much.